right, we're going to continue working on our geometricity, and we're going to focus now on triangles, okay? So, we know triangles, three-sided shape. Thank you, Mr. Cordero, for that. But there are two different ways in which you can classify triangles, because not all triangles are equal, or the same, I should say. Not all triangles are the same. So you can define a triangle by its sides, and we'll go over those. You can also define a triangle by its angles, all right? So let's begin. We're going to work our way just across here. The three ways to define a triangle by its sides are equilateral, which if you've been doing your GLARPs, should be very obvious as to what it is. Scalene, and isosceles, which also is GLARPed. So let's look at the first one, equilateral. Let's look at the word and break it down. Equa, we know that means equal or the same, and lateral we know refers to sides. So since this is how it's defined by its side, this is a term from there, just by the name we know equilateral means equal side. And with a triangle that means all three sides are equal. Okay, this is your quote-unquote perfect triangle, equilateral. Right. Equal sides, boom. Next is your scalene triangle. And your scalene triangle is a little wonky, and it's gonna look like that. And your scalene triangle, if you look at the word itself, you'll see the word scale in there. I always remember it because all three sides are a different scale or a different size. Okay, this is smallest, this is mediumest, and this is largest. Okay, so it's three different sides. That's your scaling. Okay, and isosceles, again, if you break down the word, you look at the front, iso, which is the same root as isolation, meaning left alone, you have a triangle that has one side different than the other. Okay, so these two sides are the same, and you got this poor little dude down here, he's all isolated, he's not like the rest. Okay, one side is different. Okay, so unlike the scalene where all three sides are different, when you get your isosceles one, you just have the one side that's different, all right? So that's how you define your triangles by their side. Now let's look at how you define them by their angle. Okay, and those terms we're going to use are right triangle, acute triangle, and obtuse triangle, which going all the way back to 16-1, you have an idea of what those angles look like, or 16-2, whatever it was. You have an idea what those angles look like. Now let's put them into play with a triangle. So you know with a right triangle you have to have some angle in there that's 90 degrees. So I'm going to begin by drawing my 90-degree angle, and then I'm just going to connect them. Boom. Kobe. There is your right triangle, okay? It has one 90-degree angle. You can't draw a triangle that has more than one, so don't try. You have one 90-degree angle. An acute triangle has three acute angles, okay? Acute being less than 90 degrees. So, there we go. All three of these angles are less than 90 degrees, all right? Hey, you may notice that looks like the isosceles. Yeah, and that's okay. It can be one or the other because they're being quantified, or excuse me, they're being qualified by sides or angles. It's not one or the other. It could be both. And then obtuse, you can't draw a triangle that has more than one obtuse angle, but if it has one obtuse angle, it is an obtuse triangle. Boom, boom, boom. Okay? So you have right here, this angle is greater than 90, so therefore that is an obtuse triangle. Okay? Now, I remember back when I was a kid, long ago, I always had a hard time figuring out, well, which do I use? It's important to remember that some of them are qualifying these by the sides and how those are related, and some are qualifying them by the angle. And if you can keep those two things separate, you'll be able to figure out which of the three it is, all right? Equilateral, equal sides. Scalene, 3 different sides. Isosceles, one side is different. Right triangle has a right angle, but you can only have one. Acute triangle, 3 acute angles. Okay, 3 acute angles. And lastly, obtuse, 1 obtuse angle. Okay, thank you very much.